Exponents and radicals is Unit 2 of the course Applied Algebra or APA. There are 3 objectives in this unit. Objective number 1, simplify algebraic and exponential expressions using the properties of exponents. First, let's review the laws of exponents. Law number 1. This is the product rule. A to the m times a to the n equals a to the power of m plus n, meaning to say, to multiply powers having the same base, we are going to add the exponents. Example number 1, x to the power of 3 times x to the power of 4 equals x to the power of 7. Number 2, so that's a to the m over a to the n equals a to the power of m minus n if m is greater than n. That's the exponent of the numerator is greater than the exponent of the denominator. For example, x to the power of 8 over x to the power of 3, that is equal to x to the power of 5. We subtract the exponents, that's 8 minus 3. Number 3, a to the power of m raised to another exponent n, that is equal to a to the power of m times n. That means we are going to multiply the exponents. Example, if we have x to the power of 3 raised to another exponent 2, that's x to the power of 6. Law number 4, the quantity a times b to the power of n equals a to the power of n times b to the power of n. For example, if we have the quantity x times y to the power of 7, this 7 is the exponent of x, and also this 7 is the exponent of y. Rule number 5, that's the power of a quotient. We have the quantity a over b to the power of n equals a to the power of n over b to the power of n, meaning to say this n is the exponent of a and also the exponent of b. For example, we have the quantity x over y to the power of 3, so this 3 is the exponent of x, so we have x cubed over, and also this 3 is the exponent of y, so we have over y cubed. Rule number 6, it's about negative exponents. That's a to the power of negative n equals 1 over a to the power of n. So we are going to make this negative exponent positive by moving this term to the denominator and writing 1 as our numerator. For example, if we have x to the power of negative 4, we are going to make this negative exponent positive. It becomes x to the 4, but we are going to move it to the denominator and we write 1 as our numerator. Number 7, a to the power of 0 equals 1. So that's any number except 0 raised to the power of 0 is equal to 1. For example, if we have x to the power of 0, that's 1. Now, let's simplify algebraic expressions using the properties of exponents. So, example number 1, simplify the quantity 3x squared y to the power of 4 raised to another exponent 2, then times the quantity negative 2xy raised to the power of 3. So this 2 is the exponent of 3, and also this 2 here is the exponent of x squared, and also this 2 is the exponent of y to the power of 4. So this becomes 9x to the power of 4 y to the power of 8. So this 3 is the exponent of negative 2. Also this 3 is the exponent of x, and this 3 is also the exponent of y. So negative 2 to the power of 3 is negative 8. Then we have x to the power of 3, y to the power of 3. So to multiply powers having the same base, we add the exponents. First, we are going to multiply 9 and negative 8. That's negative 72. Then x to the power of 4 times x to the power of 3. That's x to the power of 7. Then y to the power of 8 times y to the power of 3. That's y to the power of 11. Example number 2. Simplify the quantity xy cubed raised to the power of negative 3 times the quantity negative 3x squared y cubed to the power of 4. This exponent negative 3 is the exponent of x, and also this negative 3 exponent here is the exponent of y cubed. So it becomes x to the power of negative 3 y to the power of negative 9, because we multiply negative 3 and positive 3. Then this 4 is the exponent of negative 3, and this 4 is also the exponent of x squared, and also this 4 is the exponent of y cubed. So negative 3 to the power of 4 is 81, then x squared, and then to the power of 4 is 8. Then we have y cubed to the power of 4 is y to the power of 12. Now to multiply powers having the same base, we are going to add the exponents. So we have here 81, then negative 3 plus 8, that's 5, and then negative 9 plus 12 is 3. So this is our answer, 81x to the power of 5 y cubed. Example number 3. Simplify the quantity x cubed y to the power of 0 raised to the power of negative 4 times the quantity negative 5xy squared raised to the power of 2. So this negative 4 is the exponent of x cubed, and this negative 4 also is the exponent of y to the power of 0. So it becomes x to the power of negative 12 and still y to the power of 0. And this 2 also here is the exponent of negative 5, also the exponent of x, and also the exponent of y squared. So it becomes 25x squared y to the power of 4. Now to multiply powers having the same base, we are going to add the exponents. So we are going to copy down 25, and then the exponent of x, negative 12 plus 2, that's negative 10, and then this is y to the power of 0. This is 1 anyway, we can ignore it. We can just copy down y to the power of 4. We are going to write the factors that have positive exponents. So 25y to the power of 4. And how about this x to the power of negative 10? From the law of negative exponents, we are going to move this x to the power of negative 10 to the denominator, making the exponent positive. So our answer is 25y to the power of 4 over x to the power of 10. Example number 4. Simplify the quantity 4x to the power of negative 3 y to the power of 4 to the power of 2 over the quantity x to the power of negative 6 y cubed to the power of 4. For our numerator, so this 2 is the exponent of 4, that's 16. We have 2 times negative 3, it's negative 6, so we have x to the power of negative 6. Then 2 times 4 is 8, so we have y to the power of 8. And our denominator, okay, x to the power of negative 6 times 4, that's negative 24. And then y to the power of 3 times 4, that's y to the power of 12. Now to divide powers having the same base, we are going to subtract the exponents. So first we are going to copy 16, and then negative 6 minus negative 24 is 18. So this is the exponent of x. So for the exponent of y, it's 8 minus 12, it's negative 4. Now we are going to write down the factors with positive exponents. We have 16x to the power of 18. Then we are going to move this y to the power of negative 4 to the denominator, making the negative 4 positive. So this is our answer. 16x to the power of 18 over y to the power of 4. Objective number 2. Simplify radical expressions using the properties of radicals. So example number 1, square root of 25. 25 is a perfect square. What are the perfect squares? We have 4, 9, 16, 25, 36, 49, 64, 81, and so on. Why are they called perfect squares? So this 4 is actually 2 times 2. This 9 is 3 times 3. Then this 16 is 4 times 4. Then 25 is 5 times 5. Then 36 is 6 times 6. 49 is 7 times 7. And 64 is 8 times 8. Then 81 is 9 times 9. So the square root of 25 is just a 5. Example number 2, square root of 48. So 48 is not a perfect square, but we can factor 48 such that one of the factors is a perfect square. So in this case, it's 16 times 3. So 16 is a perfect square. And the square root of 16 is 4. And the 3 stays under the square root sign. So this is our answer, 4 square root of 3. How about if we are going to include variables or letters? Example number 3, square root of 72 L m squared n to the power of 3. So for letters, they are perfect squares if their exponents are divisible by 2. So in this case, m squared is a perfect square. N cubed is not a perfect square, but we can factor n cubed so that one of the factors is a perfect square. The factors of 72 are 36 and 2. Then we have L here, cannot be factored anymore. Then m squared is here. Then we are going to factor n cubed. That's going to be n squared times n. Now among these factors, 36, m squared, and n squared are perfect squares. So the square root of 36 is 6. Square root of m squared is just m because we have the exponent 2 here. So when you say square root, so the index is 2. So 2 divided by 2 is 1. So the exponent of m is 1. And also square root of n squared is just n. And 2l and n stays under the square root sign. So this is our answer, 6mn square root of 2ln. Example number 4, 6 times square root of 2ab times 3 square root of 3a squared b. So since the indices are the same, 2 here and also here, so we can multiply first the coefficients. That's 6 times 3, that's 18. And also we can multiply the radicands. So 2 times 3 is 6. Then a times a squared is a cubed, and b times b is b squared. So we can factor a cubed. So that's a squared times a. And b squared, it's already a perfect square, so we don't need to factor. Now the perfect squares here are a squared and b squared. The square root of a squared is a. The square root of b squared is b. So this a and b will join the 18. Now this 6 and a stays under the square root sign. So our answer is 18ab square root of 6a. Example number 5. This time, it's the cube root of 250 a to the power of 6, b to the power of 10. And these are some of the perfect cubes. 8, 27, 64, 125, 216. So this 8 is actually 2 times 2 times 2. 27 is 3 times 3 times 3. 64 is 4 times 4 times 4. 125 is 5 times 5 times 5, and 216 is 6 times 6 times 6. Now 250 is not a perfect cube, but we can factor 250 such that one of the factors is a perfect cube. If the exponent of the variable is divisible by 3, that's a perfect cube. So a to the power of 6 is a perfect cube. B to the power of 10 is not a perfect cube because 10 is not divisible by 3. However, we can factor b to the power of 10 such that one of the factors is a perfect cube. So let's do that. So the factors of 250 are 125 and 2. Then a to the power of 6 is still here. It's a perfect cube. Then the factors of b to the power of 10 are b to the power of 9 and b. So we have 125, a to the power of 6, and b to the power of 9 are perfect cubes. So cube root of 125 is 5. Cube root of a to the power of 6 is a to the power of 2 because that's 6 divided by 3. That's 2. Then cube root of b to the power of 9 is b to the power of 3. So that's 9 divided by 3. And then this 2 and b stays inside the cube root sign. So we have the answer 5a squared b cubed cube root of 2b. Objective number 3. Simplify radicals by rationalizing the denominator. So example number 6, 21 square root of 20 over 3 times square root of 2. First, numerical coefficients. We have 21 divided by 3 is 7, and then square root of 20 divided by square root of 2 is square root of 10. So we don't have radical in the denominator, so this is the simplest form. Example number 7, 30 square root of 7 divided by 2 square root of 3. So we can divide 30 and 2, that's 15. So that's 15 square root of 7 over square root of 3. But we cannot divide 7 and 3 because 7 is not divisible by 3. So in this case, we are going to rationalize the denominator. How? We are going to multiply both the numerator and the denominator by the square root of 3. 15 square root of 7 times square root of 3 equals 15 square root of 21. While square root of 3 times square root of 3 is just 3. Why? Because square root of 3 times square root of 3 equals square root of 9, and square root of 9 is 3. Furthermore, we can divide 15 by 3. So our final answer here is 5 square root of 21. Now how about if our denominator is of this form? Example number 8, 3 over 3 plus square root of 2. To rationalize the denominator, we are going to multiply both the numerator and the denominator by the conjugate of 3 plus square root of 2. And the conjugate of 3 plus square root of 2 is 3 minus square root of 2. For our numerator, 3 times the quantity 3 minus square root of 2. And for our denominator, because we are just multiplying the sum and difference of two numbers, we can just multiply the first terms. So that's 3 times 3, that's 9. And then multiply the second terms, that's positive square root of 2 and negative square root of 2, that is just negative 2. 9 minus 2 is 7, so we can write 3 over 7 times the quantity 3 minus square root of 2. So this is our answer for item number 8. Item number 9, 6 over 1 minus square root of 10. Now to rationalize the denominator, we are going to multiply both the numerator and the denominator by the conjugate of 1 minus square root of 10. And the conjugate of 1 minus square root of 10 is 1 plus square root of 10. So for our numerator, we have 6 times the quantity 1 plus square root of 10. And for our denominator, again, because we are just multiplying the sum and difference of two numbers, we can just multiply the first number. So 1 times 1 is 1. And then negative square root of 10 times square root of 10 equals negative 10. Now 1 minus 10 is negative 9. So we have 6 times the quantity 1 plus square root of 10 over negative 9. And we can simplify 6 over negative 9. That's negative 2 over 3. So our answer here is negative 2 over 3 times the quantity 1 plus square root of 10. Thanks for watching, guys. This is Teacher Rejil. Keep safe.